Good afternoon, guys. We are group TY33 from Computer Engineering Department. We are group members Rag Jadhav, Dheeraj Kakade, Jiva Shirke and Shilendra Jadhav. Our project name is BrailleCraft. We are trying to implement BrailleCraft, that is transcripting Braille from sign language. So communication is a fundamental human right. Every individual should inherit it. But we see that many individuals such as deaf, mute people and blind people find it hard for communicating through the normal means of communication. That is, the blind person can't talk with the deaf person and the deaf person can't communicate with the blind person. So we are trying to bridge this gap. We are proposing a system that would convert real-time sign language to a Braille text that would be interpreted by the blind person. Now, how it would work is that the deaf and mute person will give sign languages and that would be interpreted by our system. It would convert it to text, and this text is then converted to Braille for the blind person to read. The introduction, this was a problem statement. Moving forward. Now we will look towards the methodology of our project. So first part in our project is the data acquisition and collection part. So firstly what we did is we captured all the raw images from the starting from A character to the Z character, and for each character we collected up to 250 images for the next part, like pre-processing, and then for the model part. Then we we used the media pipe framework for the hand landmarks coordinate to detect the hand landmarks, and all those landmarks were stored in a CSV file, and this CSV file contains 21 into 3, like there were 21 rows and three-dimensional rows from x0, y0, z0 till x1, y1, z1 till x20, y20, z20, and this all represents from the base of the hand till the tip of the hand, like starting from the x0, like from the base till the x20, like the tip of the hand. So all these coordinates were mapped in a CSV file, and this CSV file was further passed for the pre-processing part. In this pre-processing, we did the scaling, we did the rotation, scaling, translation, noise, and horizontal flipping. Like for rotation, we did from we kept the angle from minus 30 degree to plus 30 degree. Like if the hand is between minus 30 to plus 30 range from the expected answer what we need for the particular character, then it would give the prediction. Then we did the scaling from the factor 0.8 till 1.2. Like for if the hand of my friend is less thick and small, it will give accordingly, and if my hand is slightly bigger, then it would be given a correct output. Then we did the translation for the next is the noise part. We have used the Gaussian noise and we have kept it the value 0.01. Basically it is used for the lighting issue. If there is any lighting issue, then it will solve the particular problem. And then for the last step we have used the horizontal flipping. So if the hand is left, right, then it would give the same output even though the hands are different. For that we have used the horizontal flipping. Then we come towards the model architecture. We have used the random forest machine learning model for the training purposes. In that we have passed the CSV files for the training from the alphabet A to L, and then the second model from alphabet M to Z for the training purposes. So what this model does is it divides the data set into a random data sets into multiple decision trees, and for each decision tree the output is calculated, and lastly the majority voting is done through the entire decision trees, and one common like classifying element is taken as an output. Then we have the hardware integration part. So in that we have used the Arduino Uno solenoid cells for the push-pull of the Braille display board, and it provides the tactile feedback to the visually impaired persons which are blind. Now we will see the demo part. Now this is the GUI of our project BrailleCraft. Here we can see the predicted character. Then this is the confidence ratio. In the confidence percentage, it is calculated by the taking the the highest number of percentage from the decision tree of the random forest and multiply with the 100. It will give the confidence. Now let's try with the word college. So this is C O L L E G and E. Okay. Now we'll see the this buttons and its features. So here add letter feature is there. So once we click it, then we can add those letters which the predicted character in the GUI has displayed. Then we have add space, like if we want to add new word, let's say if I want to add A, then it will be added in the after a space given by the other word. Then there is delete feature. We can delete the particular word, and clear all feature. We can clear all the letters. And also there is save text feature. The text will be saved in a txt file. This is the txt file that we have generated through the GUI, and also we have generated a report for the testing part of all the characters. So here we can see, just zoom it. Yeah, so for majority of them the confidence level is high, but for the similar characters the confidence gets decreased.
So let's move to the hardware integration part of our project. So here, which uses the tactile feedback mechanism using solenoids. So here is the entire system where we are using Arduino Uno. There are 6 MOSFETs are there, and NP channel diodes are there, and the 6 solenoids are connected here. And we are using the power bank for the external supply voltage. Here how the system is working. So here each MOSFET has 3 pins, first is gate pin, drain pin, and the source pin. So gate pin is connected to the power supply of external source, and the drain pin is connected to the diodes, and the source pin is connected to the ground via Arduino Uno. So what will happen here? So when the voltage is supplied to the gate pin, it will regulate the current flow between the drain and the source pin. And the NP diodes will work like NP diodes have the 2 materials, that is N-type material and P-type material. So N-type material is consist of the electrons, and the P-type material is consist of the holes. And what will happen? Electrons will pass to acquire that complete holes, and it act as a barrier to move the current only in one direction. So the current is passed to the solenoid, and after the output is passed to the Arduino to the solenoid, it will trigger the solenoid, and it will work on the push-pull mechanism.
So this is the Braille language. The Braille language, in our English alphabet there are 26 character, and in a 26 character we represent this 26 character in the Braille using the dots. So the dots are arranged into the 2 columns, and the 3 rows are here. A uses only 1 dot, B uses 2 dots. So this mechanism we use in our hardware projects. We arrange our 6 solenoids in the 2 column and 3 row fashion. So how this solenoid will work? Suppose A is triggered by our hardware, then this solenoid will work. Inside the solenoid there are wires which generate the electromagnetic field, which will trigger this pin to go upwards, and the blind person will detect this character is on. So in first module, we using the sign language, we created text which is a college text. The college text will be passed to the Arduino, and then in the Arduino code we implemented that college which is text will be the pass char by char, and each char will be displayed on our Braille boards. So let's do this. So this will C O L L E G E.